Greetings. My name is John Gabriel, and this is the new Calculus channel. So today, I feel like taking a little diversion and spending some time on one of my critics on the internet. He's actually a crank known by the name of Dennis Muller, and I have produced a couple of videos on him in the past. But in today's video, I'm going to just pick one of his web pages and go through it very slowly, just sharing my thoughts with you about what he says. So Dennis Muller is this particular student that you see over here. Looking at the gentleman here, he's got a nice eye ring there, or eyebrow ring, and he's into heavy metal. Who knows what else? Maybe he does pot too. I don't know. Looks like he likes long, greasy hair. Okay, well, maybe I'm not being that nice, but you know, I don't really have any mercy on individuals who attack me and who really don't know anything about mathematics, but still feel that it is their duty to go ahead and basically talk about me in a very, very, very unflattering way. So not that it matters too much, but, and of course it doesn't matter too much, because if we look at the idiot's website, which is all about me, by the way, that's how important I am. At least he's got that right. But he doesn't even really have many comments on his site, and nobody even takes him seriously, except his fellow morons who are, you know, precisely like himself. But at any rate, what I'd like to discuss is this web page today. So I'm going to just start reading through it and expressing my thoughts, okay? So first of all, this graphic here that he has comes from an article of mine, which is, let's just see here. Oh, I just need to move that out of the way there. It comes from this article here, which is called Euler's Blunder. And he doesn't really address anything that is written here in this article, completely ignores it. I don't even believe he took the time to read this article, which is unfortunate, because he would have found a lot of the things that he discusses in here have already been addressed. So the first thing that I notice here is he says he has a previous post on the Dunning-Kruger Effect. Now, I've already handled that in a previous video where he trashes my arithmetic mean. And that's really funny, because he actually confirms everything I said about it on that webpage. And moreover, in my previous video to this one, I revealed a very important new theorem. I revealed a theorem that says if you pick any point on a curve and you take equal distances on either side and calculate that area, and that point there happens to be the arithmetic mean, no matter how you change, no matter how you change that area, see, that arithmetic mean is 6, okay, then this point here is an inflection point, okay? So that is what I revealed in my previous video. So it's pretty big and pretty important stuff, which obviously people like Dennis Muller wouldn't be able to appreciate, simply because he's just not intellectually on the same level, okay? And of course, you know, I in my hurry to get this done, the first two videos, I stated the theorem incorrectly, but in this last video that I produced, it is stated correctly. So it basically says that if you choose any point on a curve, then it's an inflection point if it's also the arithmetic mean, no matter how much this distance is varied, okay? So I'm not going to spend time on that because I've already addressed it. I'm going to close this. Don't need to look at it anymore. So coming back to this page here, he says, he quotes here, this is an actual quote, by the way. I did say that. Few people can ever begin to match my intelligence. But I've noticed that anybody who accuses somebody of the Dunning-Kruger effect is truly, in effect, saying from the offset that anything he has to say is not worthwhile listening to. And why do I say that? Well, the Dunning-Kruger effect is a completely unscientific study. And it's based on a group of psychology students, I think about 50 of them at one particular university. And now remember, these are psychology students, not Bachelor of Science, as you would expect somebody in a Bachelor of Science to have a lot more critical thinking ability. But at any rate, so these students are the subjects of the study, and they're undergraduate. I mean, if I was going to look at a study, I'd probably look at the one here made in the New Yorker, Why Facts Don't Change Our Minds. Okay, so that was made on many academics with master's and doctorate degrees, and many who have advanced degrees, not just undergraduate students. Also, it was done at several universities, and it reveals how facts will not change the minds of academics. Okay, so you accusing somebody of the Dunning-Kruger effect instantly voids anything you have to say, because that means you're uneducated and you're ignorant. You're using an argument, a fallacious argument, by the way. He calls his blog logical fallacies. It's actually illogical fallacies, but let that be as it may. This guy is really funny. So I'm gonna go through this slowly, and bear with me because I'm going to reveal a lot of things to you. So that statement there is true. I'm not arrogant. It's a truth. And if I were deluded or arrogant, it's unlikely that I would have such great knowledge and that I would have discovered so many important facts, revealed so much ignorance in the mainstream, and also I would never have realized the new calculus, which is the greatest feat of human intellect. No one before me was able to discover the new calculus, which I was the first. Okay, so yes, that's an actual quote. And this LinkedIn page, by the way, if you bother to study it, I'll be surprised if even 0.2% of math academics have the intellectual ability to understand what I wrote there, or the knowledge, the background knowledge to understand it. Just visit the page and judge for yourself whether it's hilarious, by the way, because he calls it hilarious. It's hilarious, obviously, because, I mean, if a monkey looked at that page, chances are a monkey would also laugh. So at any rate, and then, he carries on some crap about mathematical means, which is whatever. He tries to start off by saying that I have some mild form of mental illness. Oh, wow. That's kind of him. Or at least a personality disorder. Interesting. He is not only a PhD student of computer science or whatever he's doing, but he also has a psychology degree, and he's a psychiatrist. So he says the narcissism and ignorance of this guy even dwarfs Donald Trump. By the way, Donald Trump is a complete idiot, and comparing me to Donald Trump already disqualifies somebody from writing anything about me. So, and here are some of the quotes. Every one of those quotes, by the way, is true. And this first one here, after Euclid and before me, not a single mathematics academic ever understood what is a number. That's quite a big statement. I mean, if you look at professors like Wolfgang Juchenheim, he has no clue what it means to be a number. Okay. A number is the measure of a magnitude, and nobody before me and after Euclid even could define number the way I have defined it. But it's precisely what I'm telling you. A number is the measure of a size or a magnitude or a quantity, okay? If you cannot measure a size, you do not have a number, because a number is that which describes a size. So, and not to spend too much time on this, George Cantor was an idiot, because his theories are just so absurd that they really can't be discussed in a logical setting. They're a mythology. They're not mathematics. Kronecker was right about Cantor, and in my discussion Well, in my attempted discussion with that fool, Mark Chukarol, on his website, I actually explained why Cantor's diagonal argument is actually not even an argument, it's a misargument. And of course, Cantor was right about the mythical set of real numbers being uncountable. Of course, if we accept that there is a set of real numbers, it's got to be uncountable because we don't know what is a real number. And there has never been a valid construction of a real number in human history. In fact, real numbers do not exist. The only numbers are the rational numbers. Square root 2, pi, and all those sizes, and I call them sizes or magnitudes, have no number which describe them. So it's, strictly speaking, ignorant, uneducated, and foolish to call them numbers. There is a big difference between an incommensurable magnitude and a number. Well, all right, I could spend a lot of time refuting this idiot, but let's just go straight into what he says here. So the first paragraph is, again, just ad hominem hearsay. I'll just dismiss it. Then he says he'll take this opportunity to explain why mainstream calculus is actually not wrong and how it works. So he says many things that Gabriel gets wrong have to do with the fundamental definitions. Example, convergence, real numbers, etc. Well, that's absolutely false because I've completed courses at university on real analysis, on calculus. I know exactly what those things are. In fact, I know those definitions and understand them better than anyone I've ever met, by the way. So if we want to see how wrong Gabriel really is, we first need to make sure that we all agree on the official definitions. Well, I don't think it's ever occurred to this poor student that mathematics is not done by consensus. It's done by pure logic, facts, and rational arguments, okay? So you can state a definition, and if it's not well-formed, I don't have to accept it, and neither does anybody else. So he says, I will assume that we all know and somewhat agree that the rational numbers are listen to this, like a thing, like a thing. Wow. Yeah, a thing can be anything, right? Numbers that can be expressed as fractions of integers. Well, in order to understand what is a number, you'd have to read my article on LinkedIn called How We Got Numbers. Muller has no clue what is a number. Being the orangutan that he is, he just fumbles around and just states what they told him at university. Okay, so there's a good reason why we say rational numbers are expressed as fractions of two integers. But then he continues and he says, the set of all rational numbers denoted by Q, blah, 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 who cares, etc. And then he says, I mention this because I will have to talk about what real numbers really are in modern mathematics. Something that Gabriel really doesn't seem to grasp. Okay, so let's not waste too much time on his vomit. He says, I'm not a historian. Oh, you poor thing. You're not only not a historian, you're not even an academic's ass. But at any rate, he says, I might get some, many of all. That paragraph you can read on your own. It's a load of crap. So now let's go to the interesting parts, the origins of calculus. Calculus was developed by Newton and Leibniz. Well, that's actually not true, by the way. Calculus was not developed by either of these individuals. Well, first of all, because neither of them understood calculus. They were just groping around in the dark. It was Archimedes who got the first concepts of calculus, and not either of these individuals. But I must say that Newton did accomplish some great works. For example, his interpolation polynomial, his discovery of the sine series, which was done, by the way, entirely without calculus. That's not common knowledge, but it's a fact. And of course, Leibniz, who was a little more systematic in that he was trying to provide a rigorous definition of the derivative and integral calculus. But neither of these individuals actually understood. They were groping around in the dark. Okay, so contrary to the statement here, calculus is not the study of continuous change. In fact, calculus has nothing to do with continuous change or limits or infinity. And if you study my new calculus, you'll see that that is proof that this statement is a bunch of hogwash. There is no such thing as a continuous rate of change. In fact, let's carry on reading. It says, but before I do, let me just tell you what calculus is. Calculus is the study of continuous and smooth functions. In fact, we could just say calculus is the study of smooth functions, because smoothness implies continuity. If we remove smooth functions, you may as well toss calculus out of the window. It's null and void. You can't do anything with it, okay? It is not applicable to anything that cannot be modeled through a smooth function. So, he says its basic objects of interest are continuous functions on the real numbers. Actually, the real numbers are not even necessary. I was the first to prove the mean value theorem constructively, and if you read my article on that proof, you'll see that real numbers are not required. In fact, real numbers are completely irrelevant. So he says its most important notions are derivatives and integrals. Yeah, everybody knows, anybody who's been to university knows that. They've memorized that pretty well, but they have no clue what are derivatives and integrals. So he'll say, we define the latter using limits of sequences. No. You define both using limits, okay? Even the derivative itself is a limit of a sequence. It's a limit of a sequence of finite different values. But how could this moron know? Because his lecturers never told him that, okay? So both of them are a study in the mainstream, not in the actual calculus, the new calculus, which is the only rigorous calculus. So this definition here, and then he says, for which we have to thank Augustin Louis Cauchy and Carl Weierstrass for. The epsilon delta criteria are just properties of functions that have smoothness, okay? So if we look at this diagram, this applet, which I created, by the way, and I use this in my teaching, I show that basically the finite difference, which is this expression here, is never, ever, if we go to zero, we'll have a problem if we go to zero. Let's just see if, oops, click on there and go to zero. Oh, it's that way, right? Oh, I think I passed it. If we go to zero, that green line disappears. Okay, let's just go there. See? In other words, you cannot have this criterion here. It doesn't make sense, okay? All right, so now you can even look at this in terms of truth tables using epsilonics. If I move this point outside of the region, then there's no definition for either of these. It's not even applicable. So all that the epsilonics are saying is that if there is a limit, in other words, it's defined here at this point, and by the way, it is defined, it's not just a limit and not defined, you can't punch holes in functions, as we'll see in a little while, then of course, the statement here verifies. It will tell you that for any given epsilon greater than zero, there is a delta. That means there is a mapping from this distance into this vertical distance, okay, using these epsilons. So really, epsilonics don't tell us anything. They don't prove anything. You need to know the limit, by the way, to use this verification. And you don't know the limit, okay? And this is adequately demonstrated in my little graphic here, which is hated very much by academics. So I'll come back to this maybe later on. But at any case, Muller has no clue what is calculus, okay? No clue at all. He's just regurgitating what he was taught. So he says, however, in Newton's and Leibniz times, the limit of a sequence wasn't yet a well-defined notion. In fact, it was never well-defined because there isn't any such thing as a real number. Not even an infinitesimal number. Okay, so he goes along here and he's saying, so here's approximately their thought processes. All right, let's see. So he says, what is the slope of this function here, the quadratic at x equals to 4? He says, then he blabbers on about some crap, and then he says, obviously it's not increasing at the same speed. Excuse me, nothing is increasing at any speed. Speed in this case here is completely irrelevant. Do you get that, morons? This is y is equal to x, 1 over 10 times x squared. It's nothing to do with speed here. Nothing is changing. All these tangent lines have been here in past perpetuity. They have nothing to do with speed, and nothing is changing. So let's just do something over here. So what he's saying is, come on, come up. Whoops. I don't know why this isn't coming up. That's strange. All right, let's see here. Okay, somehow I'm not able to bring this up for some reason. Never mind. I wanted to draw something. Perhaps if I bring up a paintbrush, I might be able to do that. All right, so let's do this. So in here, what he's saying is this. He's saying that we've got a function like this, quadratic function, and he's saying that these slopes change. Well, of course they change. They're tangent lines at different points. They don't really change. They've always been there. I should say, of course, they've always been there. The slopes that they change is no remarkable thing at all. Of course they're going to change because they're at a different point of the function. But nothing is changing here. This function has been, and always will be the same. There's no change. In fact, instantaneous change is not even relevant in this case, okay? So let's go back here. So he says, otherwise the graph would be a straight line. No. It wouldn't just be a straight line because it's defined by this function here. So how can it be a straight line? A straight line is defined as f of x is equal to x. So obviously he's been indoctrinated and brainwashed so badly that he says, so how can we find out how fast the function is increasing? You can't. The function, speed has nothing to do with the function. This isn't even a time function. It doesn't have a time differential in it. It's completely bogus, okay? So then he says some crap here about that's an absolute growth of 2 in the interval of length, and he gives a length here, and then he says on average the function grows by a factor of in that interval. No, the function isn't growing or diminishing. None of that is happening. This is just the slope of the tangent line at a particular point. There's no increase or decrease or anything. Nothing has changed. Then he mentions the example of a car, but you would never be able to calculate the instantaneous speed of a car, because in order to do that, you'd have to calculate this finite difference that I'm giving you here. You'd have to know its value when h is 0. You can't, unless you know the function itself. If you know the function, then you can calculate the speed at a given point, right? If it's a speed function or a speed, distance, time function. But there's no way you can use this here to say, this is the instantaneous rate. There isn't an instantaneous rate of change. There's no such thing. It's a myth. So, and then the interesting part comes in here where he says, and here's Newton's and Leibniz's mental leap. If we decrease the distances between the points to where it is infinitesimally small. Wow. Now you're getting into new territory. You have to know what is an infinitesimal. But what on earth is an infinitesimal? And never mind infinitesimal, but what is infinitesimally small? They're both bullshit concepts. There is no number greater than 0 and less than every other number. Do you get that? And that is how an infinitesimal is defined, by the way. It's a number greater than 0 and less than every other number. Now, of course, if you're a moron like Arthur Rubin, who's one of the Wikipedia administrators, he'll tell you that there's a very small subset just close to 0 in the interval 0 to 1, which contains all those infinitesimals. They're just hiding in there. You can't actually touch them. And then he tries to, in a discussion I had with him many years ago, tries to show me what an infinitesimal is, but he fails dismally. So Muller, coming back to Muller, he says, let's assume we have some infinitesimally small delta x, whatever that means. Oh, whatever that means. Let's assume we have a piece of crap, whatever that means, because that's what it is. Then the derivative is given by, no. The derivative is never given by that, you moron. That's a finite difference. To get the derivative, you need to know the slope. Okay, so let's just clear this all out. Okay, let's clear this. So to know the derivative, if this is a function and we have a tangent line, okay, like that, and to get the derivative, we need to know, I should have actually drawn that closer. Okay, so imagine that this tangent line is touching at this point here, okay? So the derivative is the slope of this tangent line at that point. What you see here in terms of the finite difference quotient is just an approximation. This here is what you'd call monkey business. Newton and Leibniz didn't know any better. They were just trying to get the answer by approximating secant lines closer to the tangent line. Okay, and they understood tangent correctly. In other words, they knew that a tangent never goes through a curve, not even at the origin of x cubed. Okay, and thank goodness they thought that way, because if they didn't, you may not have had calculus today. But coming back to this point, that's what is a derivative. It's not this crap that he says here, f of x plus delta x minus f. It's not given by that. Okay, that's nonsense. So then he says, and so the reasoning goes that this here is an infinitesimally small number. Actually, I don't know what is an infinitesimal small number, because there is no such thing. But in order to get the exact derivative, I would need x over 5, which is this here. And the only way that that is possible is if this here is 0, okay? So there is no number I can multiply by 1 over 10 that will make it 0 except 0. So he's telling you that you have to set delta x to 0. And then he says, it's just an infinitesimally small number. Yeah, it's monkey business, and hence ultimately negligible. We can ignore it and get that. No, you can't get that unless you set delta x equals to 0. And there's no arguing against that, okay? In other words, the mainstream calculus you have is absolute bullshit. And I don't care if you come back to me and you tell me, oh yeah, but we can first find it by this rough guess using the shitty method here, and then we can check it using our epsilonics verifinition. So in other words, if you can't find it using your shitty method, because that's what L is, it's how you find your derivative, it's your guess. All right, so in other words, you must guess what is your derivative, but if you've guessed it wrong, you're fucked, because convergent sequences have only one limit. Do you understand that? So idiots like my friend Wolfgang Muckenheim thinks that this kind of knowledge or Cauchy criterion is useful. But the idiot doesn't realize that in order to even use this, one has to know the value of L, okay? You can't use this unless you know the value of L. How do you get the value of L? You use this bogus arithmetic here to find it, okay? There's no other way to do it. And I've addressed that in a previous video with the idiot Muller. But let's continue. So he says, what the hell are those infinitesimal numbers? That's right, Muller. What the hell are they? And then he says, what's all this about? What is it supposed to, quite right, what is it all about? What is going on here? And then he says, well, the thing is, it sort of works. It sort of works? Excuse me, it sort of works. Actually, it doesn't work. That it either works or it doesn't work. There isn't a sort of works. You get that? Mathematics is not sort of. It either works or it doesn't. At least for relatively simple functions. No, you moron. It works for all functions or it doesn't work. Okay? Now, and then he says, but infinitesimals were never quite satisfactory. And he actually contradicts us later on, by the way, because he says they were satisfactory through non-standard analysis, which is Abraham Robinson's bowel movement. But he says, which is why Cauchy and Weierstrass tried to put, you're right, they tried to put the whole thing on a more solid basis, but they failed. They failed miserably. Okay, so Cauchy and Weierstrass, the result of the culmination of all their efforts was this bullshit here that you see in this box, okay? Which is unremarkable because once you know the limit, it's obvious that if you're in this region, you can get epsilon, you can get a delta for any epsilon you choose. It's obvious, isn't it? If I move out of there, then I can't, right? Then I can't get it. But if I'm in there, there is an epsilon, okay? So it's going to be true as long as I'm in there. But if I'm out of there, it's not even relevant if I'm out of that region. That's what this is saying. It's saying that as you decrease the distance of the x coordinate, okay, so let's just get there. As you can decrease the distance between x and the point, it means that this distance for the y coordinate, this distance here, will also decrease. That's all it means, okay? That's what this whole mountain of bullshit is all about. And it's completely unremarkable. It doesn't rigorize anything. Moreover, by the way, the function has to have an inverse on that part of the domain where you're calculating the limit. If it doesn't have an inverse, then there's not going to be a limit. Do you understand that? Because this point is mapped into y, okay? So around this limit point, everything must be smooth already. So it's so circular that one can't even know where to begin. I mean, if you can't see this, you're obviously a complete and total moron. Let's go to the original Cauchy definition. So this is what Cauchy said. He says, function f of x given between two known limits of variable x is a continuous function of this variable provided that for all values of x taken between these limits, the numerical value of this difference here infinitely decreases. So you see, Cauchy still used infinity and infinitely. And then all that Weierstrass did was he reworded it, because in this particular applet that I showed you, if you can keep on finding a smaller delta, right? What does that tell you? If you can keep on finding a smaller delta, it means you can keep on going ad infinitum, doesn't it? But it just doesn't use the word infinity. And that's all right that you can find it, because now you already know what the derivative is. How does that help? And so you're going on indefinitely, you see. So there's a lot of circularity here. And mainstream academics are orangutans. They haven't seen these things. They don't have my intelligence. Nobody before me ever saw how this is flawed, okay? And that's what led me to the new calculus, to discovering it. By the way, well-formed knowledge is never invented. It is realized or discovered. So then Cauchy came up with his definition of continuous, okay? And this is the definition of a continuous function. And of course, it has to be defined at f of alpha. So going back to our cranks page, and then he starts his little episode on on limits and differentiality and sequences. So nice little parroting of what he has taught here. And he says there's something fundamentally different on the two. So pick an arbitrarily large number, blah, blah, blah. Everything that you learn in a basic real analysis course, nothing new there. Okay. And nothing remarkable about it. So he says, we could say that the limit of the sequence is infinity, but infinity is not a number per se. Oh dear. Anyway, of course it's not a number. And so he goes on, and he finally gets to this definition of, well, actually it's a very definition for any arbitrary small rational number. Think about that. What does arbitrarily small rational mean? Okay, a number mean. What does it mean? Okay. Do tell me what that means, because I have no idea what that means. That reeks of infinity to me. If it can be arbitrarily small, it means it can keep on getting smaller, right? And how small is small? So, you know, it's actually a miracle that somebody who sits through a real analysis course can actually stay sane after having to take an exam on this crap. So he says, okay, this looks a bit complicated. Actually, it doesn't look complicated. It's just it's nonsense. There's nothing to it. So he says the sequence converges to some number L. Really? How do you know that L is a number? Does pi and square root 2 have a measure? How can it be a number? We can get arbitrarily close to L, but you don't even know what is L. You're only dealing with an approximation at any given time. So what if you can get arbitrarily closer to L? How does that matter even? It doesn't matter at all, by the way. So this epsilon delta game is a ruse. It's actually a red herring meant to get you off track. It doesn't matter that you can do that. I would expect that one should be able to do that. If not, then you don't have a smooth curve, and there's nothing to discuss. There's nothing further to discuss if you don't have a smooth curve. It's got to be there. It's completely unremarkable. And then he steps right into the dung with this particular function here. What most idiots won't realize is that this here is not in its reduced form. It's actually f of x is equal to x plus 1. And the function is defined at 1, okay? Because x plus 1 means that if we have 1, the corresponding y value will be 2. So you cannot just take a function multiplied by x over 1, x minus 1 over x minus 1, and punch a hole in it, okay? So you cannot take x plus 1. Let's just clear this out. And I've covered this in many other videos. You cannot take x plus 1, multiply it by 1, by the way, and then say it's no longer defined at 1. Bullshit. Okay? If you're allowed to multiply this by 1, surely you can divide by 1, can't you? Of course you can. So but there's a special reason why these idiots do this. And it has to do with this definition here, the original definition where it says for epsilon greater than 0 and also all delta greater than 0. That's another thing about these definitions. They vary depending on what function you're using. So the epsilonics will vary according to what kind of function you're using. It's not the same definition throughout, okay? And so at any rate, he says this function is not well defined at x is equal to 1. Actually, it's very well defined. You can put 1 in there after you've canceled out x minus 1, okay? So he says f1 doesn't exist. Of course it exists. As I've shown you, this here is not in its reduced form. If you place it into its reduced form, then it is correct to say that f of 1 is equal to 2. So he says then, in fact, the function is equal to the function x plus 1 everywhere except at x minus, no. It's also equal to x plus 1 even at x minus 1, and its value is 2. That's what it is. And so anyway, he carries on here just a load of crap, which I'm not even going to bother to address. He doesn't understand what he's doing. And here's the next definition, limit definition. So here we have another one. For every arbitrary small rational number, again, your guess as to what is arbitrary small is as good as mine. I have no idea what it is, okay? And if it can keep on getting smaller, what's the smallest it can get? You can't say 0, and you can't say infinitesimal because neither of those exist, okay? So this little parrot knows how to recite and repeat what he's been taught, but he doesn't understand. He's never understood. Okay, so let's continue down here. And then finally, he ends off by saying, you'll note that this is exactly what Newton Leibniz did, except that we got rid of those pesky infinitesimals and only used notions. I'm sure it's, a good mathematician uses notions. Nope. Mathematicians don't use notions. They use facts, logic, and things that are rigorous, not bullshit, like you see on this page, okay? So he says, furthermore, all of this works perfectly and beautifully. Well, it doesn't. Otherwise, you wouldn't have created this page. Would you have, moron? Okay. So anyway, I've finally gone through every one of those paragraphs. I believe I've addressed everything this idiot has said in here. And perhaps at some other time, I'll take a look at this page here again, this hilarious one where he deals with the Dunning-Kruger effect in a nutshell. So he tried unsuccessfully here. All right, let's look at this. He says, this is very interesting here. And he says, so he comes up with these little diversions here. To be a crank, you either don't know enough about the subject to realize you're wrong, while at the same time, or you think you know enough to boldly proclaim your wrongness to the public. So, I mean, that's not even wrong because it's not even relevant. So I don't know why he came up with that. And then he's got an interesting little trichotomy here. And he says, if something in science doesn't make sense to you, you have to conclude that either, one, research scientists are all incompetent, they're all in a conspiracy to deceive you, they know something you don't, and you need to find out what that is. Okay, so I can definitely conclude that 1 and 3 are 1 is true and 3 is false. Okay, so people don't know something that I do not know because I've studied the mainstream calculus, so I'm very well aware of what they have to say. The irony is they haven't studied what I have to say, and that's pretty sad because I'm actually showing them that they're wrong, proving to them, not only showing them, but proving to them that they're wrong, and they are still persisting on their incorrect path. Okay, so are they all in a conspiracy to deceive me? I don't think so, because they cannot deceive me, and I'm not deceived by bullshit. I mean, my bullshit detector, if you want to call it that, was as sharp as can be ever since I was a young child. I wouldn't fall for rot, and I started studying calculus at a very young age. In fact, I taught myself calculus. By the time I was 14, I could calculate line integrals. I could do multivariable calculus. I knew more than any of my professors at university. Those morons who I met in South Africa. That's where I went to university, in South Africa. They were all a bunch of stupid ignoramuses who didn't know the first thing about mathematics, never mind calculus. Okay? So he says he has reinvented calculus. Actually, I have produced the first and only rigorous formulation of calculus. So, and then the funny part is the arithmetic mean. I've already addressed this section in another video, so I'm not going to go all over it again. But believe it or not, if this was not as important as I say it is, and he goes ahead here to confirm that what I'm saying is correct, shows how he actually confirms everything I say, by the way. Exactly what I say about the arithmetic mean, he confirms it, and he doesn't understand it. Now, if I was wrong about that, then I would have been wrong about my latest theorem too. Okay, it's actually not my latest theorem. It's a theorem I discovered many decades ago, but which I only revealed in the past 4 days. It's a very useful theorem, and there are a lot more theorems that I haven't revealed and a lot more that I haven't shared. I don't like writing for several reasons. I'm not a good writer. My eyesight is not that great, and it's very stressful for me to have to answer to every criticism that I get on the internet. I don't, and it's a waste of time. But I really felt that I needed to, once again, address this criticism from Dennis Muller, because he appears to be erudite, and I mean, if you look at these comments here, you'll see how stupid, you know, his fellow academics are. So, you know, but the real numbers aren't countable because they don't exist. Yes, that's correct, Julian Yarecki. They don't exist. If they did exist, you'd be able to list them systematically because, let me tell you, a set is countable if and only if its members can be systematically named. That's what it means to be a countable set. And I was the first to state it that way. And the way I am stating it is correct. The way every other fucking moron who came before me stated it is incorrect. They do not understand what Cantor was thinking. I do, because I'm smarter than they are. It's as simple as that, okay? So none of these fools here, these pothead fools, have even come close to my ability to understand mathematics or calculus. They're just jealous, basically. All this here is really trying to cast doubt on what I'm telling you. You get the fucking moron Jean-Pierre Massager on Sci.Math, who is all over the place. I think he's unemployed right now. He probably got kicked off his last job, which is a good thing. But there are many fools who get on the internet and will try to ridicule me and make it look as if I have a mental illness. Well, let me tell you, I don't know of anyone who has my mental soundness and ability. I've never met anyone who is as controlled as I am. And let me tell you something else. You wouldn't be able to walk half a mile in my shoes, not even if you could live 1,000 lifetimes. Okay, so I think I've chatted a lot. I had a lot of energy today. I hope you've enjoyed that. I'm going to stop the recording now, and I'll see you again on the New Calculus channel next time. My name is John Gabriel. Goodbye.